Okay, part of your proof's essential skill is proving triangles are similar. Remember, if you're proving triangles are similar, you have three options. Could be side-side-side similarity, side-angle-side similarity, or angle-angle similarity. For each letter in the proof, you need a bubble in your flowchart. So if you're going to try to say a side is similar, it should look like the ratio of two sides and whatever that value is, and then your reason is calculations. If you're going to prove an angle is congruent, you should say the angles are congruent and whatever the reason is. The reason might be vertical, it might be given, it just depends on the picture. So our first example, prove whether the triangles are similar, is what that should say. The reason we're doing this in video form is so that you can pause it and try to do the problem on your own, and then play again and see if you did it right. So one of the first things I notice when the triangles are built like this is that we have vertical angles here and here. So one of my bubbles in my flowchart could say those two angles are congruent. But remember, we need to use three letters when we talk about an angle, and the vertex needs to be the middle one. Angle DCE is congruent to angle BCE. The reason I knew that was because they're vertical angles. Another thing I see in this picture are the double arrows. Remember, that does not mean that the sides are congruent. It means that the sides are parallel. If I have parallel sides, then, for example, angle A is going to be congruent to angle E because of alternate interior angles. So that can be my second bubble. Three letters, middle letter is the vertex. Pause it and see if you can fill out that bubble in our flowchart. So angle CAB, or BAC is fine, is congruent to angle DEC because of alternate interior angles. Now that I have two angles congruent, because this is just a similarity proof, those bubbles lead me to triangle DCE is similar, make sure you only use the similar symbol, to triangle BCE. And the reason we know that is angle-angle similarity. So notice I have two angles in my similarity reason. One of them comes from the green bubble. The other one comes from the orange bubble. The number of bubbles you should have depends on which similarity reason you're going to use. Here's problem number 2. Take a second, pause it, see if you can come up with the proof that these triangles are similar. So looking at what I have, I know I'm going to have to use those sides because I don't have enough angles. So I started with side AB over its corresponding side, which is DE, and then I did the math, 3/9, and I reduced it. All of that goes in the bubble. You don't get to just do that work off to the side. It's part of your proof. So those sides have a ratio of 1/3. Then if I look at the next pair of sides, see if you can write the bubble for the BC and EF sides. So BC over EF is 2/6, which again reduces to be 1/3. But I don't have enough bubbles up top yet because right now this is side-side, and side-side is not a similarity property. I either need a third side or I need an angle. Well, they gave me 90 degrees in the corners. So I know angle ABC is congruent to angle DEF because it's given. So draw your last bubble before we prove they're similar. So make sure you use three letters, and that B is the middle one, and E is the middle one. Then these three bubbles tell me that my triangles are similar. So maybe triangle ABC is similar to triangle DEF. And the reason is side-angle-side similarity. Again, if I'm using three letters, one of the sides is in red, The other side is the stuff I did in green, and the angle is what I did in blue. They all need to be in the bubbles up above. Last one, prove whether the triangles are similar or not. Pause it and see if you can do the similarity proof. Here's the first step that I did, comparing the smallest side on the triangle on the left with the smallest side on the triangle on the right. Gives me 3 over 12 or 1 over 4. Those are just calculations. Do the same thing with your other two pairs of sides. So comparing all the corresponding side ratios, BC over EF, 6 over 24, reduces to 1/4. AC over DF, 7 over 28, reduces to 1/4. Because they're all the same, only because they're all the same, those three bubbles let me know that triangle ABC is similar to triangle DEF. And those three bubbles are all talking about side ratios, so it's side, side, side similarity.